This is William here with, at the bare minimum, at most, a part two to part one. Now, this is going to be a separate video on its own. I would have read this in the previous part one, which was talking about the generic streaming TV stick device earlier that I talked about, but I didn't want to make the video excessively too long. I decided to split it into two parts. Parts one and two about how this happens. It's the article is written by Pedro Fale at BitSite's website. But now I'm going to actually read parts of this. I've already read this in the part one on encryption security, but I'm going to jump ahead a little bit. I'm going to auto jump a little further. Now, obviously, the article on Crimson Security already describes a shorter version of this, but this one's more in depth on the BitSite's website. But I'm going to jump to the preamble of it. There are key takeaways if you want to read the key takeaways yourself instead of watching the whole video in full. But here we go. This is going to be quite long. Preamble. This discovery, like many, happened by chance. As I was writing about the dangers to consumers when acquiring cheap Android TV boxes, I stumbled upon this. The initial research was simple, documenting factory backdoors on Android TV boxes used mostly for remote management and development, which are shipped to production and sold to consumers. The case was made that shipping this back door, which was a remote shell with full root execution, was poor sanitization practice. If the domain associated with this backdoor expired, full access would be granted to over 400K devices inside homes and companies, free to install any additional apps and explore other devices within the same networks. Uh-oh. Our team at BitSite Trace managed to register this domain as it was expired. The domain in question didn't just help manage each device. I'm glad that BitSite Trace managed to register a domain before some cyber criminal could register and do something else nefarious with it at a later date. It was also used for telemetry collection. Each Android TV box would periodically send full hardware information and the entire list of installed apps. Here lay the issue. Upon considering telemetry for a period of 24 hours, we noticed something was wildly wrong. Multiple devices reporting this factory Android TV box backdoor were phones, from Xiaomi models to Huawei to Vivo to Samsung and other multiple profiles. This made no sense. There you go. The top is top 10 brands by unique devices. The sinkhole telemetry was done to see what was going on behind the scenes. But the bottom part is unique devices relative scale. Vivo, Oppo, Huawei, Honor, and Xiaomi are on there, including Samsung and others, but as a way to mimic as if it was a human doing that from a real phone visiting a website. But figure one, early highlight of phone models reporting to a TV box backend. These logs appeared to be phones through and through, minus some other minus some other minor inconsistencies. The vast majority of entries were consistent with hardware properties matching phone profiles. One thing quickly stood out by looking at the installed packages for each phone device. Some of these still had TV box related packages such as launchers, settings, and other apps. Doing some quick data analysis on the list of installed apps across every record showed two apps consistently appearing on the phone profiles and sometimes on Android TV boxes. The culprits were the first Fuyao apps. At this point, a colleague rightly pointed out, we need to get to the bottom of this. That was the beginning of the research on the Fuyao enterprise. What is Fuyao? Fuyao was the name given to this operation. Now, I already read it on the Crypton Security website, but I will jump to the next part. The Fuyao apps are shipped pre-installed on Android TV boxes, likely some form of customization via OEM distributor reselling and are spreading their customized ROMs or downloading reflashing. There are some very obvious pieces of evidence pointing to this, such as install paths and user privileges. Here's figure 2. I already read that in the previous video, part 1 on the Crypton Security website. But, however, it says that the SHA-1 sub-packages are both installed dynamically to /data/local/system. I read part of this in the previous video because if I read this part in the last video, I would automatically make the part 1 way too long to understand. So that's why I'm making it into 2 parts now. Fuyao's business model operates under its ability to always identify where an ad lives on a website. Spoofed devices are shown for more premium clicks, increasing revenue gain from each click and avoiding getting flagged as a bot by mimicking human behavior. The operators run AI content generated on websites registered legal entities as publishers under Google or Taboola. It meant to say Taboola. Literally meant to say Taboola. It says Taboola as a spelling error, I think is what it is. Obtaining the revenue for each click on every 1,000 views on the ads displayed in their websites. Revenue estimations. On a conservative estimate, I've already read some of this from Crimson Security, but the way this works here, I'm going to read this here, is on a conservative estimate of 10 clicks per device at $0.10 on average, which could vary based on the device spoofing success and other estimates such as geolocation, landing pages, etc. That would be around $1 per day per device. Add that to cost per thousand of $0.25. For impressions alone, you would get around $1.25 per device per day. It might not seem like much, but on an advertised fleet of 120,000, that would still be an astonishing amount of $150K per day. The advertised fleet is a lot higher than the confirmed fleet. Now, here we go. This is going to get quite lengthy, but it'll explain everything. Bot clicks the ad. Spoofed as a phone taps ads like a real visitor on the operator's own website or the operator's own site. The AI generated page is built purely to host ad slots. Billed as a real ad view. Site registered as a publisher with Google Ads and Taboola. Operator gets paid. Ad network pays out per click, per thousand impressions. You can read this part yourself right here if you want. Pause and read, but I'm going to read it anyway. Even for the lowball fleet of 38K devices, we managed to confirm via Sinkhole. They sinkholed this domain to prevent further trouble. It would still mean 47.5K per day. Sure, some clicks may get flagged. There might be post-fraud filtering and impressions could be invalidated due to bot traffic. But even on a 40% flag and 70% ad fill is still undeniably a massive revenue source with potential reach up to $40 million a year in revenue. We also observed some overlap with our residential proxy data, which confirmed this botnet is also likely sold as residential proxies, passively adding another revenue stream on top of the ad fraud scheme. Next, we will look into 3 chapters, inter-app connectivity and the novel tech powering the ad fraud and how the fraud ecosystem works, and finally, the attribution linking the active campaigns of mainland China Corporation for profiting from the scheme. The apps. After restless nights of going down the analysis rabbit hole dealing with several versions of mostly huge 60 megabyte APKs, the APKs are 60 megabytes in size, very large. I'm glad to synthesize it all for you, starting with the capabilities of this botnet. The Fuyao suite has 2 modes, running in full mode or just a proxy run. Below, you can see an image depicting a very high-level overview of the Fuyao system. The factory makes the Android TV box with the code on it, or makes the Android TV box, put the Fuyao apps in it. They do the live stream, and then the C2 RSA, AES, persistent WebSocket, dynamic fraud task, and it breaks down to, and the apps break down to residential proxy fraud activity, stealth, ad fraud, revenue collected via several shell companies, ML and Blockly, internal built system registered on a Google patent, stealth. It says their Puppeteer Extra JS spoofing hardware as a phone user shards. Figure 4, Fuyao Apps Ecosystem. The Fuyao Enterprise targets Android TV boxes to use it as a base for their operational activity by having these boxes shipped with the Fuyao apps pre-installed. Threat actors possess the ability to spoof TV boxes, premium devices, phones via hardware system property changes, browser injection, and user space process execution user sharding, and much more. This app ecosystem also sends logs, periodic screenshots, and can even live stream the screen back to the C2 through the command and control server. Yikes. It also can live stream the screen back to the C2 server. This is possible via their WebRTC implementation and current C2 command suite. This fraudulent activity materializes in a robust human mimicking way. The latest versions of the app show an evolution from the pure JavaScript to automating fraud utilizing pre-trained machine learning models to improve, automate, and fail-safe fraud execution. Fraud tasks are pushed only after the client successfully completes a series of readiness tasks given by the C2. When considered a ready node, and depending on the location, a fraud task is given to the infected TV box. These ad fraud tasks are created via Blockly. We will cover this novelty feature as well as the reason behind this choice. The entirety of the Fuyao ecosystem is highly modular with functionality spread across applications. Now, I'm going to give you a little bit of a condensed version of this before I continue, but the Android TV boxes, the cheap generic ones that are dirt cheap off of Amazon and other retailers, Newegg and others, are infected to do things like this. They're literally infected by the manufacturer. They're just infected that way to do stuff like that. The Center app serves as an orchestrator that performs device checks, proxy service, and is ultimately responsible for orchestrating between the C2 and other sub-packages like script and remote. The following image provides an overview of this inter-app connectivity. System update spoofing, Fuyao Center, embedded WebPetcher spoofing, remote control and live stream remote, script, execution of tasks and ad fraud, info, logging. The Fuyao interact connectivity. The Sensor app is also responsible for communicating and maintaining a persistent WebSocket connection with the command and control infrastructure. The existence of these two packages, script and remote, has been fairly consistent through time, while some other packages have been removed. I should say. System update exists in the parallel with the Sensor app, but not on every model. Is responsible for the process of spoofing and changing Android TV box hardware properties into mobile phones. Although this capability seems to have been migrated into the Sensor app later on. WebPetcher comes embedded within the Sensor app. It is a dedicated headless browser that injects stealth.min.js into every page it visits, also spoofing system properties such as CPU, GPU, etc. Tech on a box, UI perception. One of the distinctive qualities in the Fuyao Enterprise is that their approach that enables ad fraud. Allow me to explain. Traditionally, ad fraud and social media botnets relied on purely scripting automations such as DOM injection. Notice it's DOM, not the other kind of DOM. No, not the disk on module either acronym. Breaks easily on UI updates or native accessibility service scraping, implementing a singular approach. Fuyao instead fuses three vision and reasoning systems into a single interface. Android accessibility nodes, NCNN-based YOLO object detection, and Google MLKit OCR using VLMs to augment and create a failsafe for ad detection. Here's a bit of a note. The script app ships with a YOLO V8S. You only look once object detection model named LOURUI_2 inside the assets folder. Now, here we go. What is YOLO V8? YOLO V8 is a computer vision model architecture developed by Ultralytics, the creators of YOLO V5. You can deploy YOLO V8 models on a wide range of devices, including NVIDIA Jetson, NVIDIA GPUs, and Mac OS systems with RoboFlow interface and open source Python package for running vision models. The computer vision model is pre-trained and acts as the eyes of the bot as a failover when attempting to identify an ad on a web page, allowing to navigate the user interface visually, much like a human would. The yellow model, named Low Yuri underscore 2, has been trained to recognize 12 distinct types of objects, such as buttons, search fields, etc. That function is an ad layout classifier. We have also seen some exploratory code around this using Azure GPT instead, although the developers seem to have strayed away from this option, leaving the deprecated code behind. See below the pre-trained ad layout classifier VLM and a note regarding Azure GPT. In figure 7 here, it shows Fuyeo fuses accessibility, computer vision, OCR, optical character recognition, so a bot can see and click ads like a person. Bear with me. Two classifier classes quickly stand out being purely ad related. ADV, generic ad banner regions, Taboola around the web, content recommendation widgets. These are explicitly used in the context of ad networks. The rest of the classes focus around the page navigation, header, footer, search bar menu, etc. Loyuri underscore 2 param can also be loaded into the Netron.app for clear visualization. See the image below. Right, here's the image. Now, here we go. The decisions are split into two specialized streams. One focuses exclusively on the location of a button, while the other focuses on the classification of what the button actually is. Nonetheless, this already indicates enough that the actor has a grasp on ML architecture and showcases they're keeping up with the implementing ML research in their processes, molding to their needs. They also developed their own customization of the Android features, allowing them to converge the three data sources into the subsequent downstream benefits of using Android accessibility. This process and many others which they patented will be further detailed in the first part of a two-part upcoming technological blog post, Anatomy of a Fuyeo box. That's not available yet, so it'll be available at a later point. When that becomes available, I will be able to do a video part 3 based on this once when they release the technological blog post as a part 2. But my video will be in parts 1, 2, and 3. Azure GPT 4.0. From what I've observed over time in Fuyao, or however you pronounce it, the actors have sought to improve an already existing process or add flexibility, resilience to this process with the usage of AI. AI might lower the barrier for some, but I believe that for more experienced actors, it's a tool that can improve existing workflows for scale and flexibility. For those interested in reading a little more about this evolution adoption behind or beyond the hype, I really recommend reading the Human Security post on AI-powered fraud. That's on the Human Security right there. You can click on that, things like that. Just go to bitsite.com and you can see this right here in the URL, the web link here, right there, so you can actually type that in. Or I may implement a QR code where you can scan what you're shown to get to this site easier in part 2 and things like that. So I could interject a QR code in where you can scan to read yourself to this site as a way to get to it there. From what I was able to tell, there's a lot built around its usage, but it's not hooked up anywhere in the code. So it seems to be deprecated, scaffolding left behind. Its usage, however, is very apparent as it was being implemented for decision making on where to click and rational on where to navigate next. Residential proxy. Still within the box, the sensor app also runs a foreground server. The role of this proxy server is to turn the infected device into a residential SOC 5 exit node. The device will continuously pull the HTTP endpoint of /app/device/get box proxy server to fetch the proxy back connect servers. These R servers of box will then establish a persistent tunnel connection to and be forwarded traffic. This tunnel is layered between standard net Netty pipeline and custom protocol encoder and decoder. The custom protocol was split into two: an outer custom layer handling the session metadata, and an inner layer using by using standard SOC5 payload. I'm going to continue to read more on this. Within the encrypted metadata, a local channel ID allows the Shuyayo app to multiplex several concurrent proxy sessions over a single netty tunnel between the TV box and the back connect bridge. One tunnel, many concurrent SOC5 sessions. As previously mentioned, there is an overlap with residential proxy data. Even though we have limited visibility, we could still see that at least 1 in 6 Shuyayo boxes overlap with our residential proxy data in a 24-hour period, and 1 in 4 for a 7-day period. That means the Fuyeo operators are very likely to rent out their bandwidth to commercial residential proxy providers. An overwhelming majority of over 90% of the Fuyeo boxes performing residential proxy only had the Center app installed, matching our initial assessment of the Fuyeo app's workflow, where check self parentheses mostly translates to run proxy when the HDMI cable is on, run ad fraud when the HDMI cable is off. So it monitors the HDMI cabling signal. If it's on, it'll run proxy, but when it's turned off the HDMI signal, it'll run ad fraud. So it has a bit of a Dr. Jekyll and Mr. or I should say a Dr. Jekyll and Mr. Hyde-like appearance. It may look like an innocent streaming box, but at the same time it's doing ad fraud when the HDMI cable is off and doing ad proxy when the HDMI cable is on. So it's kind of flipping between two different modes when the user interacts with it. So it's kind of doing a Dr. Jekyll, Mr. Hyde type thing. Or it may look nice to have a streaming box or a TV stick and all, but some of those are generic devices that are going to have malware in them, and they may look like a Dr. Jekyll, Mr. Hyde appearance. The fraud, the Fuyeo enterprise consists of multiple tiers of C2s. Each serving different purposes. The system, however, relies on a set of the hard-coded IP addresses and ports for initial contact and to posteriorly establish persistent WebSocket connections. One tier dedicated initial contact, a second to spoofing, and a final for the persistent WebSocket. There are also S3 buckets for sharing configs files. Spoofing. This subchapter focuses on the spoofed phone profile being sent by the C2 server. This happens under the endpoint /app/device/getbox model. While we had some success requesting to the endpoint directly, with 40 requests over different days, we only got 7 distinct profiles returned, even though the universe of spoof profiles is much larger. Here's why. In the example below, you can see a decrypted C2 response to enforce a complete spoofing of the Meizu M3 Note phone profile. It attempts to mimic a Meizu M3 Note, things like that. It attempts to mimic as such. Phone profile attempts to mimic and appear as such. The properties config is merged between the base config and the provided diff config. It can also delete properties related to platform-specific identifiers from Rockchip, Amlogic, Allwinner, and others. They also make sure that the spoof version doesn't diverge from far from what the underlying ROM actually exposes in order to reduce detection of inconsistencies. The spoofing properties are likely real phone profiles, which has been a trend somewhat alluded to recently by Castle Research. It became clear the spoof template assigned probabilities weights, which dictate how frequently each profile is deployed. These weights varied across days, so there's likely server-side logic that rotates these campaign weights because there are actually hundreds of spoofing profiles. We're going to cover this by recursing to our initial backdoor telemetry domain, which led to this entire research. All devices reported to the domain with a payload containing device model and other system properties such as brand, board, firmware version, CPU, and many other fields. As you can imagine, this was a researcher's goal. Below is an example of an entry. So in this image, it shows an entry of everything as an example, like a gold mine. This reporting also came with a packages field that discloses all current packages in the device, and we observed both the sys server dot system update and the FUAO apps packages in these devices. The FUAO apps were found mostly H96 underscore max underscore V11, which could definitely be skewed due to the domain being present in older models, but they were also observed in spoofed devices reporting as phones. Sinkhole phone spoofing. After parsing a sample of 24 hours of logs associated with the backend sinkhole domain, filtering exclusively for entries that reported FUAO apps installed, we got the following statistics. 65,957 device reports across 38,000 unique MAC addresses, and most of them were not the phones they claimed to be. The sinkhole data was taken earlier this year from February 2026. Now, this image shows the sinkhole telemetry of the device doing the shady things behind the scenes. System update and elf.center are pre-installed versus on demand. Slate baked into the firmware everywhere, which is the grayish black color. Orange equals pulled on demand only when tasked. So the percentage for pulled on demand only when tasked is lower than baked into the firmware everywhere is a lot higher. The sinkhole telemetry. First two packages on the right are universally pre-baked into the firmware. Although the unique MAC count of spoofed phones profiles likely overestimates the physical device counts depending on how spoofed identities rotate, the domain only gives us visibility into some older TV box models from one brand. So the true universe of affected devices is probably larger. Blockly, enterprise ad fraud. Probably one of the most fun chapters in the blog post and something I've never seen documented before. A complete novelty. The operators use Blockly, a visual programming language usually reserved to teach kids learning to code to construct on their side logic and behind extremely modular fraud task, which then gets pushed to the TV box. Blockly is a Google-built visual programming language where you can drag blocks together instead of coding. Yes, this is what all those languages that help kids learn programming with ease now use underneath. And FUAO is using this in the middle of their fraud process. Some of you might remember learning programming with Scratch 3.0, which uses Blockly technology to create its blocks. In Blockly, you can still export the underlying code in several formats, one of which is JavaScript. Google Blockly Homeplay. Ugh. Google Blockly homepage. I got tongue-tied almost trying to say that. Try saying Google Blockly homepage several times fast. And the threat actors use it on their build side, which goes hand in hand with the commercial enterprise-like feel on this whole operation. An operator can drag blocks together in their Blockly editor to define each fraud routine given a task type. Once the routine is saved, it gets exported as JavaScript JS and uploaded to S3 buckets. The client executes this JS and it actually never sees this Blockly structure. An operator doesn't need as much understanding of the underlying technicalities as it is all set in place for ease of use. Some quick wins with the operator are authoring, speed, reusability, and visibility. We actually found a FUAO developer mentioning exactly these advantages. The comment translated to the following: only a small number of highly skilled developers are needed to build execution unit images. Developers who create execution units from those templates have significantly lower technical requirements, greatly reducing the company's operating costs. If the device is chosen in the long list of devices for a fraud specific task, a push message event called push task module triggers a chain that ends with the browser on the box clicking ads on the websites. The fraud task comes with a pre-configured target, website browser distribution, click and cache cleanup probabilities, and bounce rate target. When the push task module event arrives, it comes with a script module snapshot zip link to a modules.txt file. Inside there were links to about 56 ad fraud modules created using Blockly. The following are approximations of what the Blockly blocks could look like on the operator side. Of course, it's not one-to-one, but a visual approximation due to the operators having built their own Blockly editor containing the fraud-specific custom blocks. In general, most modules would have the size of the ones depicted below so you get an idea. Here we go. Once a device starts receiving these tasks, it means it has successfully passed all C2 checks and is now a trusted node within the botnet ready to carry out fraud tasks, fraud modules. After registering some devices to this network, running two separate runs, a first run for the 24-hour and second run 2 hours. In that second run, we registered 4 unique devices and were able to capture around 40 fraud tasks and extract meaningful insights. From the 40 tasks, some of them were duplicated. 21 unique campaigns were identified, each pointing to a different destination site. There. Overall, we got 166 unique Blockly modules pushed and split them into following three major groups. 25 core modules include browser, tabs, and telemetry. 32 functionality modules, swipe profiles, browser decision fallbacks. 109 single target modules, logic that exists exactly for each targeted website. Here's 7 distinct categories right here. Now, browser decisions is role based on input args, Firefox, Edge, Opera, probability, install a browser missing, stuff like that. It says your browser hygiene, white cache between rounds, bot navigate settings, browser specific, tab management, close tabs the bot opened in a prior round, browser launch and state, open a specific browser and reach a known clean state. Per browser variants exist because each browser launch UI differs. Scroll, browse, simulate reading times, page navigation, ad detection and engagement. Ad clicking related combines the machine vision, long press and compare ad context to page domain, etc. Session timings, homepage load time, and ad load time. Target specific, usually modules that contain reference to destination site or self-operated. Essentially, the fraud resumes to be the following: browser orchestration across 4 major browsers, telemetry channels, ad detection, browser hygiene. A new campaign target spin up will bring its own URL, click rate, browser mix ways, and only a handful of site target specific modules. These ad fraud task modules returned by the C2 will be detailed and made publicly and available in the technical report. Fraud publisher ecosystem. Who benefits when a Fuyao bot clicks an ad? The Fuyao enterprise runs an ad publishing portfolio using the botnet as a captive traffic source that clicks on the ads on the operator's own pages. The advertisers pay cost per click CPC, and every 1,000 views often referred to as cost per mile CPM. The operators of the Fuyao collect the publisher payout by faking this traffic. This chapter follows a trail from the URLs the bots hit to how these targeted websites are structured, and finally the legal entities collecting the ad revenue behind it. By the end of this current research, we were able to map 144 operator-owned domains, likely larger than several beneficiary entities, and the bridge identified the operators mainland Chinese incorporation. First, let's step into what these landing pages look like and how they operate. These pages exist across several different categories: finance, health, food, etc. The content on them seems to be AI generated, with articles being published on a daily basis. See below some examples of this. Now, you might be thinking, where's the advertising? The websites employ their own client-side scripts that will only show the advertisement section of the devices, i.e. Android or mobile, etc. The criteria of these scripts differ per website and per advertising network, such as ads only rendered to bots and have freshly cleared cache or accepted the consent banner. But if everything went correctly, you would see these sections. See below. These sections were not only run on the main page, but across several of the pages of the website, including articles about us, page disclaimer, about us, page disclaimer, privacy policy, etc. Operator clustering. By the end of this research, we were able to map the 144 operator-owned domains across several beneficiaries clusters. Keep in mind the total corpus of the monetization websites is likely larger still. These websites are also spun up and removed on flagging. So basically, the websites spin up and then disappear when flagged rapidly. It's like a whack-a-mole for that. Getting paid when a bot clicks, there's the image there in figure 17 right here. This mapping was done with efforts on recursive pivoting and attribution to legal entities, either individual or organizational shells. This clustering was conducted according to Bula Slugs via the publicly available sellers.json JSON information, where each domain will have the corresponding registered legal entity to collect the revenue. The JSON is JavaScript object node. Out of the 144 domains, at least 84 loaded the Taboola tag inline HTML via the homepage. This enabled us to identify some of the beneficiary shell companies and individuals, including Hong Kong and Singapore entities. Now, here we go. This is the last stretch of this. It's a lot to read in one video. Victimology. Who are the victims? There are two sides to this story, advertisers and ad networks. Let's start with the first. Advertisers are being defrauded because they pay to promote content or being led to believe that they're getting their money's worth of visibility and engagement, except that they're not. It's all bots. Advertisers can be individuals like both you and me, and small businesses such as your local bakery and construction store, or even massive corporations. In the case of the advertisements shown in the Fuyo ad landing pages, we have seen it all. Because the Fuyo ad landing pages exist across more than 12 verticals: finance, lifestyle, health, education, gaming, music, just about anyone paying for advertising can become a victim. We are not privy to the internal algorithms used at Google AdSense or Taboola that perform the ad selection or what are on and where to display, as these can vary substantially based on country, age, website content, and web searches and other user data. What do we know is that what we have seen, from your local fireplace store to popular online course platforms to retail giants such as Temu. I call it crap moo. I call Temu to crap moo, just because Temu sells stuff that looks all promising and exciting in the photos, but when you actually get the item, it's not as described sometimes, if not often. Not as described when you get it. Second victim, the ad networks. Companies such as Google, Taboola, and others are victims too. They employ dedicated teams that create and manage complex algorithm systems to detect bot traffic, and yet in a consistent cat and mouse game, cyber criminals always seek to innovate and bypass this. This is one such case. So if you're working in one of those teams and would like to obtain more insight about this threat, feel free to reach out. Next, we break down the attribution, some key findings resulting from a long investigation linking a China-based enterprise to the Fuyo operation. I've already read this in the Krebs on Security article, but I'm going to jump further ahead. The trace, the Fuyo and Fingwo. 4 pieces of evidence that irrefutably connect Fingo to the Fingo group to the Fuyo operation samples, domain certificates, and e-learning platform, links to ad revenue shell companies, and registered patents. The domain fwgcloud.com shows cross-shared SSL certificate data with other domains associated with the Fuyo apps, specifically the phone spoofing mechanism. fwgcloud.com also has an internal wiki platform wherein some files are left public. These files directly tied to the proprietary ad fraud Blockly system and code actively pushed by live C2s during ad fraud campaigns. Multiple other connections can be made between the Fuyo Operation Fingo group, including reused emails between ad fraud revenue collecting shell companies and the mainland China company. So here we go. So here's the end. We made it to the end finally. Lastly, something I'll just briefly highlight in this non-technical post. This is the mainland China company responsible for FWGcloud.com and its AI digital humans. It holds 20 patents and applications under the China National Intellectual Property Administration, CNIPA. I'll call that for short. Quickly skimming through them revealed invaluable insight. At least 6 or 8 of them clearly map one-to-one onto subsystems BitSight trace research in the Fuyo app fraud operation, including app code logic, some even sharing the same internal naming, therefore undoubtedly attributed to the Fuyo enterprise operation to the Shingo Group subsidiary. We will cover more details around infrastructures, including C2s and indicators of compromise, Blockly fraud models, and ad landing websites, and shell entities in mainland China operation our follow-up technical post, Fuyo ad fraud as a product. So make sure to stick around. So this is the end of the video, and this is William signing out. See you next time. Goodbye. And I will provide a link in QR code form so you can scan it with your phone to get to this directly.